Hey everyone, Asian Guy here, and today I'm bringing you some information that sounds like science fiction, but it's rooted in very real developments happening right now. We're talking about silver, lunar bases, and a potential price trajectory that could take this precious metal well past the $100 mark. This is purely an informational video to help you understand what's driving these predictions and the technologies involved. Now, before you click away thinking this is just another wild speculation piece, let me be clear. Major space agencies and private companies are actively working on lunar infrastructure right now. NASA's Artemis program aims to establish a permanent presence on the moon by the end of this decade. SpaceX, Blue Origin, and other private entities are developing lunar landers and cargo systems. China and Russia have announced plans for a joint international lunar research station. This isn't distant future talk anymore. This is happening within the next 5 to 10 years. So why does this matter for silver? Well, let's start with where silver stands today. As of January 2025, silver is trading in a range that most analysts consider undervalued relative to its industrial applications. We're looking at prices that have been hovering between $23 and $32 per ounce over the past couple of years, with occasional spikes during market uncertainty. But here's the thing, even at these levels, we're already seeing supply constraints. Global silver production has been relatively flat, averaging around 830 million ounces annually. Meanwhile, industrial demand has been climbing steadily, particularly from the solar panel industry, which consumed approximately 140 million ounces in 2023 alone. The electronics sector takes another 240 million ounces. We're talking about a market that's already tight, with above-ground stockpiles declining year over year. Now imagine adding an entirely new source of demand, one that doesn't exist on any current industrial forecast. That's what lunar-based construction represents. Let me explain why silver is uniquely positioned for lunar applications. Silver has the highest electrical conductivity of any metal, the highest thermal conductivity, and the highest reflectivity. These aren't just impressive stats, they're critical properties for the extreme environment of the moon. On the lunar surface, you're dealing with temperature swings from 127 degrees Celsius in direct sunlight to minus 173 degrees Celsius in shadow. You need materials that can handle these extremes while maintaining peak performance. Silver fits that requirement perfectly. But it's not just about surviving the environment, it's about efficiency. When you're 384,000 kilometers from Earth, every gram of material you transport costs approximately $1,000 to $10,000 depending on the launch system. So whatever you bring needs to work at absolute maximum efficiency. Silver delivers that efficiency in ways that alternatives simply cannot match. Let's talk about the first and most obvious application, solar power. Any permanent lunar base needs reliable, continuous power generation. Unlike Earth, the moon has no atmosphere to diffuse sunlight, meaning solar irradiance on the surface is actually more intense and consistent. Solar panels are the obvious choice, especially on the lunar equator, where you can get near continuous sunlight. Here's where silver becomes indispensable. The best commercial solar panels use silver paste for electrical contacts and bus bars. These silver components are what capture and transmit the electrical current generated when photons hit the silicon cells. Current terrestrial solar panels use about 10 to 12 grams of silver per panel. For lunar applications, engineers are designing more robust panels that might use 15 to 20 grams each to ensure longevity and maximum efficiency in that harsh environment. Now, how much power does a lunar base need? NASA's initial Artemis base camp concept calls for at least 40 kilowatts of continuous power just for basic operations. That's roughly equivalent to powering 4 or 5 average American homes. But that's just the beginning. As operations expand to include manufacturing, resource extraction, and life support for more personnel, you're looking at power requirements in the hundreds of kilowatts, potentially megawatts, within a decade. To put this in perspective, generating 100 kilowatts of solar power on the moon would require approximately 400 to 500 square meters of solar panels, accounting for efficiency losses and system redundancy. At 15 grams of silver per panel, and assuming each panel is about 1 square meter, we're talking about 6 to 7.5 kilograms of silver just for the initial 100 kilowatt system. That's roughly 200 to 240 troy ounces. Doesn't sound like much, right? But remember, this is just one base. China is planning its own international lunar research station. The European Space Agency has concepts for a moon village. Private companies like SpaceX have discussed lunar infrastructure to support Mars missions. Multiply that silver requirement by 5, 10, eventually 20 different installations, and suddenly you're talking about tons of silver being allocated to off-world applications. But solar panels are just the beginning. Let's discuss communication infrastructure. Any lunar base needs constant, reliable communication with Earth for command and control, scientific data transmission, and emergencies. The moon is tidally locked to Earth, meaning one side always faces us and one side always faces away. Bases on the far side will need relay satellites in lunar orbit and multiple ground stations with high-gain antennas. These communication systems rely heavily on silver. Satellite dishes use silver plating on their reflective surfaces to maximize signal strength. High-frequency transmission cables use silver conductors because signal loss through silver is minimal compared to copper or other materials. When you're transmitting data across 384,000 kilometers of space, every fraction of a decibel matters. A single large satellite dish might contain 2 to 5 kilograms of silver in its various components. A comprehensive lunar communication network could require dozens of these installations, both on the surface and in orbital relay systems. Then there's the manufacturing aspect, which is where things get really interesting. One of the key goals of lunar settlement is in situ resource utilization, meaning using what's already on the moon to build more infrastructure. This reduces the cost and logistical nightmare of shipping everything from Earth. Lunar regolith, the dust and rock covering the moon's surface, can be processed into construction materials. 3D printing with this regolith is already being tested. But here's the catch. These 3D printing systems, especially those creating electrical components or precision parts, need conductive materials. Silver-based inks and pastes are used in advanced 3D printing for creating electrical circuits and components. Every manufacturing facility on the moon will need these materials. We're talking about building habitats, rovers, scientific equipment, and eventually even spacecraft components on the lunar surface. Each of these applications requires conductive materials, and silver is the gold standard, pun intended. Let's talk about life support systems, something that doesn't get mentioned often in commodity discussions, but is absolutely critical. Silver has powerful antimicrobial properties. It's been used for centuries to purify water and prevent infection. In the closed-loop environment of a lunar base, where recycling air and water is essential for survival, silver plays a crucial role. Water purification systems on the International Space Station already use silver-based technologies. Lunar bases will need even more robust systems, because they'll be supporting larger crews for longer durations. Silver-copper ionization systems can purify water without the need for chemical treatments that create toxic byproducts, a major advantage when you can't just vent waste into an atmosphere that doesn't exist. The antimicrobial properties of silver also make it valuable for coating surfaces and habitats to prevent bacterial and fungal growth. In a confined space, millions of miles from the nearest hospital, preventing infection isn't just good practice, it's survival. Now let's get into the numbers that really matter. How much silver are we actually talking about here, and how does that translate to price pressure? According to various space industry analyses, the initial phase of lunar base construction, spanning roughly 2025 to 2035, could require anywhere from 50 to 200 metric tons of silver for the various applications I've described. That's between 1.6 million and 6.4 million troy ounces. To put that in context, annual global silver production is about 830 million ounces, but remember, existing industrial demand already consumes nearly all of that. Adding even 2 million ounces of new inelastic demand, meaning demand that must be met regardless of price because there's no substitute, creates significant market pressure. But here's the exponential factor. Lunar infrastructure isn't a one-time build, it's continuous expansion. Every new habitat module needs solar panels, wiring, and communication systems. Every new scientific installation needs power and data transmission. As lunar resource extraction begins, probably targeting water ice at the poles or rare earth elements in the regolith, those operations need their own infrastructure, all of which requires silver. Historical precedents show us what happens when new technologies create sudden commodity demand. When solar panels became economically viable in the early 2000s, silver demand from that sector exploded from negligible amounts to over 100 million ounces annually by 2020. That demand helped drive silver from around $5 per ounce in 2003 to nearly $50 per ounce in 2011. The smartphone revolution created similar pressure on various rare earth elements and metals, multiplying their prices several times over within a decade. The electric vehicle transition is currently doing the same thing for lithium, cobalt, and nickel. Lunar base construction represents a similar technological shift, but with one key difference. It's not just one new application, it's an entire new economy. And unlike terrestrial industries where alternatives can sometimes be developed, the extreme requirements of lunar operations make silver's unique properties nearly irreplaceable in many applications. So where does $100 per ounce come from in these projections? Now let's break down the math. If we assume lunar demand adds 5 to 10 million ounces annually by 2030 and continues growing from there, that's roughly a 1% increase in total demand against a supply that's already maxed out. In a tight market, even a 1% supply deficit can drive significant price increases. But it's not just about lunar demand in isolation. It's about what lunar bases represent. the beginning of off-world industrialization. If humanity successfully establishes permanent lunar infrastructure, the next step is Mars, asteroid mining, and deep space exploration. Each of these requires similar infrastructure, similar materials, and yes, similar amounts of silver. Investment banks and commodity analysts who have modeled this scenario suggest that silver could reach $60 to $80 per ounce just from terrestrial demand growth in solar and electronics over the next decade. Add lunar infrastructure demand, and suddenly $100 per ounce becomes not just possible, but likely according to these models. Some of the more bullish projections, particularly from space industry analysts, suggest silver could reach $150 or even $200 per ounce. If lunar industrialization accelerates faster than current timelines suggest, and if other space ventures, particularly private sector initiatives, expand more rapidly than expected. There's another factor worth considering: the symbolic and psychological impact on markets. When major space agencies start announcing specific silver procurement contracts for lunar missions, when SpaceX or Blue Origin reveal the silver content in their lunar lander systems, when the first lunar solar panel farm comes online and reports show tons of silver being utilized, the investment community will take notice. Silver has always attracted both industrial buyers and investment speculators. The combination of tangible, mission-critical industrial demand from the most advanced technological endeavor in human history, plus speculative interest from investors who see the long-term trajectory, could create a perfect storm for price appreciation. Now, I want to be clear about something. These projections assume successful lunar-based development on the timelines currently proposed. Space exploration has a history of delays. Budgets get cut, technologies take longer to develop, political priorities shift. The Artemis program has already experienced several delays. China's lunar station timeline has been adjusted multiple times. If lunar-based construction gets pushed back by 5 or 10 years, then obviously this demand doesn't materialize on the projected timeline. Silver prices would still likely rise due to terrestrial demand, but perhaps not to the levels we're discussing here. There's also the supply side to consider. If silver prices start climbing significantly, mining companies will increase exploration and production. Higher prices make previously uneconomical deposits viable. This increased supply could moderate price increases, though there's typically a lag of several years between price signals and new mine production coming online. Recycling also becomes more attractive at higher prices. Silver is already heavily recycled from industrial applications and jewelry, but recovery rates could improve with better incentives. However, much of the silver used in solar panels and electronics is effectively lost in landfills due to the small quantities per unit and the cost of recovery. Lunar silver would face similar challenges, though in an even more extreme sense, since recovering and returning materials from the moon would be prohibitively expensive. What about alternatives? Could other materials replace silver in lunar applications? This is a question researchers are actively exploring. Copper has better conductivity by volume and is cheaper, but it oxidizes and has lower conductivity by weight. Aluminum is lighter, a crucial factor for space applications, but has only about 60% of copper's conductivity and much less than silver's. For some applications, particularly where weight savings are critical, engineers might accept lower efficiency with aluminum or advanced composites. But for high-efficiency solar panels, high-frequency communication systems, and precision electronics, silver's properties are difficult to match. There's also research into carbon-based conductors like graphene, which could theoretically replace metals in some applications. But graphene production is still expensive and difficult to scale, and its behavior in the extreme lunar environment isn't fully understood. For the near to medium term, meaning the next 10 to 20 years, silver remains the practical choice for most critical applications. Let's talk about what this means for Earth-side industries and economic impacts. If silver prices do climb to $100 or higher, several things happen. First, terrestrial industries that use silver will face higher input costs. Solar panel manufacturers, electronics companies, medical device makers, all will see their material costs increase. This could slow adoption of some technologies, particularly solar energy, unless panel efficiency improves enough to offset the higher material costs, or unless manufacturing processes can reduce the amount of silver needed per panel. The solar industry has been working on this for years, reducing silver content per panel from about 100 grams a decade ago to 10-12 grams today. Further reductions are possible, but face diminishing returns. Higher silver prices also make silver mining more profitable, potentially leading to increased investment in mining operations, exploration, and processing technologies. Countries with significant silver reserves, like Mexico, Peru, China, and Australia, could see economic benefits from increased production and exports. For investors, the question becomes how to position for this potential trend. Physical silver, whether coins, bars, or exchange-traded funds backed by physical metal, is the most direct exposure. Silver mining stocks offer leveraged exposure. meaning they tend to amplify silver price movements, both up and down. When silver prices rise, mining companies' profit margins expand significantly because their production costs are relatively fixed. There are also companies developing technologies specifically for lunar and space applications. Aerospace contractors, solar technology firms, and communication equipment manufacturers working on lunar projects could benefit from increased demand and funding. However, identifying which specific companies will be the winners requires significant research into their lunar project exposure and contract pipelines. One interesting aspect of this story is the international competition factor. The new space race between the United States, China, Russia, and private entities isn't just about prestige or scientific discovery. It's about access to resources and establishing industrial capability off-world. Countries that can efficiently establish lunar operations gain strategic advantages in space access, resource utilization, and the technological expertise that comes from solving these incredibly complex problems. This competition could accelerate timelines as nations seek to establish first-mover advantages. If China announces a major breakthrough in lunar base construction, or if SpaceX demonstrates reliable, low-cost lunar cargo delivery ahead of schedule, it could trigger accelerated investment from competitors, which in turn accelerates silver demand. There's also the question of lunar resource extraction itself. The moon has metal deposits, including possibly silver, though in what concentrations and accessibility remains unknown. If significant, accessible silver deposits are discovered on the moon, and if extraction becomes economically viable, it could theoretically add to supply. However, this scenario is likely decades away. The initial focus of lunar resource extraction will be on water ice for life support and propellant, and perhaps helium-3 for potential fusion energy applications. Mining, refining, and transporting silver from the moon back to Earth would be prohibitively expensive compared to terrestrial mining for the foreseeable future. More likely, any silver or other metals extracted on the moon would be used for in-situ construction, keeping that supply loop entirely off-world. This would reduce the amount of silver needed to be launched from Earth, but would not add to Earth as supply. Looking at the bigger picture, silver's potential role in lunar industrialization represents something profound. The transformation of a precious metal from primarily a store of value and terrestrial industrial commodity into a truly strategic resource for humanity is expansion beyond Earth. Throughout history, control of strategic resources, whether it's oil, rare earths, or uranium, has shaped geopolitics and economics. Silver could be joining that list. The timeline for all of this is compressed compared to historical commodity cycles. The Bronze Age transition took centuries. The Industrial Revolution unfolded over decades. The Digital Revolution happened in years. Space industrialization is being measured in mission timelines and budget cycles that span just years to a decade. If the Artemis program puts boots on the moon in 2026 as currently scheduled, and if base construction begins in earnest by 2028 or 2029, we could see material silver demand for lunar applications emerging by the early 2030s. That's less than a decade away. For commodity markets that tend to move slowly, this is breakneck speed. Current silver market dynamics already show some interesting patterns. Despite relatively stable prices in recent years, physical demand has been strong. The U.S. Mint has reported record sales of silver eagles. Investment demand for silver bars and coins remains elevated. Industrial users are reportedly securing longer-term supply contracts to ensure availability. These could be early indicators of market participants positioning for tighter supply conditions ahead. The silver-to-gold ratio, which historically averages around 60 to 70 ounces of silver per ounce of gold, has been persistently elevated in recent years, sometimes exceeding 80 or even 90 to 1. This suggests silver is undervalued relative to gold. If silver catches up to historical norms while gold remains stable or rises, that alone could push silver prices substantially higher, even before lunar demand factors in. What's particularly interesting is how this story combines multiple investment narratives into one. You have the precious metals narrative, the industrial metals narrative, the space exploration narrative, the clean energy narrative, since so much lunar infrastructure ties to solar power, and the technological innovation narrative. Each of these individually attracts different investor communities. Combined, they create compelling interest across multiple market segments. From a pure information perspective, watching how space agencies and private companies disclose their material requirements for lunar missions will be crucial. When NASA or ESA releases detailed specifications for Artemis-based components, those documents will contain clues about silver and other material needs. When companies like SpaceX or Blue Origin announce lunar lander payloads, the material composition matters. When mining equipment manufacturers discuss lunar resource extraction systems, their power and communication requirements translate directly to silver demand. The scientific literature is also worth monitoring. Papers on lunar construction techniques, in situ resource utilization, life support systems, and power generation often include material specifications that reveal silver utilization. Industry conferences like the International Astronautical Congress or the Lunar Exploration Analysis Group meetings discuss these technical details. Commodity tracking services and industry publications are starting to pay attention to space-related demand for various materials. As this demand materializes, we'll likely see more detailed analysis and forecasting specifically focused on the space economy's impact on terrestrial commodity markets. One final consideration: the psychological and cultural impact of humanity becoming a multiplanetary species. When lunar bases transition from science fiction to live video feeds of people working on the moon, when children grow up knowing that humans permanently live and work off-world, it changes perspectives on what's possible and valuable. The materials that enable that transformation gain significance beyond just their price per ounce. Silver, already treasured throughout human history for its beauty and utility, could gain additional cultural and strategic importance as the metal that helped humanity take its next great step. That intangible value is hard to quantify in price projections, but it shouldn't be dismissed. So that's the comprehensive picture of how lunar-based development could drive silver prices to 100 per ounce or higher. It's a combination of unique material properties, technological requirements, supply constraints, exponential demand growth, and strategic importance, all converging around one metal at a particular moment in human development. Whether this scenario unfolds exactly as projected depends on numerous factors: the pace of space exploration, technological developments, economic conditions, political will, and market dynamics. But the foundation is real. Space agencies and private companies are actively building lunar infrastructure. That infrastructure requires specific materials with specific properties, and silver checks many of those boxes better than any alternative. All right, that's the information I wanted to share with you today. This is a developing story, one that will unfold over the next several years. The intersection of space exploration and commodity markets is fascinating, and silver sits right at that intersection. I hope this gave you a comprehensive understanding of the forces at play and why serious analysts are projecting such significant price appreciation for silver in the coming years. Thanks for watching. Asian Guy signing off.